All right, so in terms of agenda, we're going to talk a little bit about who Aviatrix is and what we do, and then we'll talk about how we're embedding security into the network as opposed to being something that you bolt onto the network. Then I've got a few use cases that we work with AWS on, kind of as a better together, because we actually are supporting some of the things that AWS is doing and adding to them with our services. So what is Aviatrix? I like to introduce Aviatrix through a lot of our customers because a lot of people don't know who we are. So if you look here, we've got about 550 enterprise customers, 60 of the Fortune 500 in almost every vertical out there. This gives you some idea. About 60% of them are in a single cloud today, but want a multi-cloud architecture because they have plans to go to multiple clouds. Now, 60 of these, I already said that, but 60% are in a single cloud, and we have about 17,000 certified, Aviatrix certified engineers. Now, this is something, if you're interested in doing certification training, we have a free code in our booth. Come by and grab that. But this is our associate degree, so you can think about this as like a CCIE, but this is for multi-cloud networking. Gartner recommends Aviatrix, saying that you should shortlist Aviatrix if you're looking for the advanced networking functionality that's missing from the cloud providers. And so this is why a lot of people start working with Aviatrix. We're an AWS partner, both networking and security competency. And this is really unique. There's only probably about 5 companies out there that are actually both security and networking. And this isn't something they give away easily. We had to go through about a 3 or 4 month process working with their product management team to actually get tested and meet the requirements for being certified in both these areas. So let's talk about secure cloud networking. Now, the way that networking is done in each one of the clouds is different because the constructs are different in each one of the clouds. Now, what we do is we have a controller that actually talks to the native constructs to talk to things like VPC route tables, VNet route tables, and then we add advanced networking and security on top of that in each one of the clouds to actually deliver the advanced networking and security. Now here we're replacing, for instance, the AWS Transit Gateway in AWS, we're replacing vWAN in Azure, we're replacing NCC in Google Cloud so that we can deliver these advanced features. And so the first thing that gives you is consistent networking. So now the way you build networking in AWS is the same in Azure, it's the same in Google, it's the same in Oracle, same in Alibaba. And that gives the infrastructure teams consistent visibility and troubleshooting, so that important day 2 operations about how they're monitoring the network, how they're troubleshooting things. It gives them consistent security across all of the clouds. So you can have a consistent network segmentation policy, for example, across all the clouds. And it gives it consistent automation. So we have a single Terraform provider that you can write one infrastructure as code module, and it will work across all of the cloud platforms in the same way. Now keep in mind that you're going to hear from a lot of different vendors out there that they do multi-cloud networking. But understand that what they mean is that they connect to multiple clouds, but they stop at the edge of the cloud and then pass you on to those native constructs that I talked about. And that makes it so that you have a different way of doing security, of doing visibility, of doing automation across all of the clouds. They're not doing the consistency that I talk about. Now let's talk about the embedded security into the network. Now, one of the things in security architecture that's been this way for a long time is that you bolt the security on the side and you force traffic through an inspection point. We're actually doing this as part of the data plane. So for instance, we see every packet going across the network, and we can compare the source and destination address to a database of malicious IPs. Now, we don't make that database. It's made by Proofpoint. But same people that work with AWS in guard duty. But what this allows us to do is say, hey, I see something in this VNet that's talking to a malicious IP. And as soon as I see that, because we control the data plane, I can put a blocking rule in and shut that conversation down. Just the conversation, not everything go into that VNet or that VPC, but just what's talking to the malicious IP. This is what it looked like to one of our customers about a year ago. And a lot of people see this diagram and they say, wow, that's a big global company. Now, this is a manufacturing company in Oregon, and all those red dots are malicious IPs talking to workloads in their cloud. And they had a good security stack that they had in the cloud, but all this traffic had to go through an inspection point to be able to see it. So they saw nothing here. We ended up finding Bitcoin mining going on, Tor servers, botnets that were doing DDoS attacks out of their cloud, all of that, and they didn't know any of that was going on. So this is how we discover things that are known threats out there. But now what we're doing is we're doing anomaly detection, where we will actually look at a VPC or a VNet environment and baseline it for 2 weeks to determine what is normal for that environment. And then we start looking for deviations to that normal. So for example, we would look at what normal ports and protocols are being used. And then if we see new ports and protocols, we're going to highlight that. Now, we're not going to shut it down because that could be perfectly normal, right? But normally what this is it's malicious code moving from server to server, and we're identifying it because it's just using some obscure ports that nobody's looking at, but because it has to go across our data plane, we see it and we'll highlight it. Now, these are some of the ways that we deliver enterprise-class visibility, which is one of the reasons that people in a single cloud will buy us over what the native capabilities can do. So we're going to show you a full topology about how the entire multi-cloud network is connected. You can see latencies on all the connections. You can drill into any of our gateways and be able to do packet capture and ping and trace route. A lot of the things that the networking guys really like to do and have been doing for years, but find it difficult to do actually in the cloud. We also can go back in time. So this is what we call topology replay. So if everything was working yesterday and now it's not working, we can scroll back in time here and see exactly what changed and who changed it. We can see every flow on the network. So we can search and sort on source, destination, port, protocol. We can drill all the way down into TCP flags to troubleshoot application issues on the network. We can also look at all of those flows as a heat map. And the security teams love this because they can say, okay, I understand why we're talking to South America, but what's going on up here in northern Siberia? And they can drill in and see exactly what that is. So normally it's people scanning, looking for open ports. But if I see a connection established, this is something I want to troubleshoot. Now, we deliver a lot of business value across multiple teams. I won't go into a lot of this, but just highlight a few of them. A lot of our customers actually say that we can help drive new revenue from new customers and even more revenue from existing customers because we allow things to be delivered faster. We increase resource efficiency. A lot of times we hear people say it used to take 5 or 6 people to touch the infrastructure to bring it up, and now they can use one lower cost resource to do all of it. And that's helping bridge the talent gap because you may have experts in AWS running in your environment, but you might be moving into Azure and need those experts in Azure or in Google. With Aviatrix, you don't need that expertise because we basically abstract a lot of that. And then we talked a little bit about some of the security features, but we have a lot more security features, but we reduce business risk. A lot of people say that we help reduce that by about 20%. Now let's talk a little bit about some of the use cases that we do actually with AWS that might be interesting. Now, already we've talked about kind of the operational visibility. We've talked about the multi-account, multi-region, multi-cloud transit. We also talked about Threat IQ with ThreatGuard, which is earlier what I was saying, we detect the threats. Here are some of the other use cases. So this is essentially building an active, high availability network. So what we do is we actually put in a particular region, we will do the hub and spoke model where we put 2 gateways in each one of the VPCs in each availability zone, and then 2 gateways in the transit VPC, and form a full mesh network. So where you would normally get a connection from a VPC to the transit gateway and get a 50 gig connection, we're going to give you 100 gig of throughput here, and it's fully high available so that if one of the availability zones go down, you'll maintain connection over one of the 50 gig links here. We also do that cross region, so we can support that same full mesh connectivity across regions. Another one is AWS Direct Connect for high performance encryption. So if you're going to do a direct connect and you want to encrypt that, you're going to get about 1.25 gig of encryption across it. With Aviatrix, we'll actually give you up to 25 gig across your direct connect, and then inside the cloud we'll give you up to 100 gig of IPsec encryption. And we do that by actually aggregating multiple tunnels and processors, and that's actually patented technology that we have. Now this is Copilot visibility. I showed you some of the screens there that we talked about, and that information is coming from our gateways and our controller feeding that UI. But one of the things I want to show you that gives you a good example is something we call App IQ. So you always get those calls from the app team saying the network is slow or the network's down, and the network team has to actually prove that it's not the network before to get out of this. So this is something we call App IQ, where you go and you can select your starting instance. Let's say this is your app server, and then your database server, another instance on the network. And then you run this, and it's going to actually go and do the full map of between this node and this node, or this instance and this instance. And it shows all of the network components in line here. So you can see that full mesh connectivity, where here I might have one availability zone down, but I have paths to be able to make this whole thing. So the network is up, but I might have lost a little bit of connectivity. I can look at every one of the instances that are in line in that network and see if there's any performance or memory issues, disk issues, anything like that. So very quickly I can see if the network infrastructure is there. And then really importantly, as I scroll through here, you can see things like network ACL configurations, route tables, security groups. Here's looking at actually our route tables on the spokes and on the transit gateways. And that's in one direction. And then I start looking at the network ACLs and the route tables and the security groups on the other direction. And so you can see very quickly there's a problem with the security groups. Just in this kept going. Just in this 20-second report, I can see that the problem is a security group. And you saw a link there, maybe, and that would take you right to an AWS console and be able to solve that problem. What this report shows in 20 seconds would take 13 different console windows to bring up, and a lot of human correlation to try to figure out where that problem actually is. So let's talk about service insertion. So we work with people like Palo Alto Networks and Checkpoint and Fortinet in bringing their firewalls into the cloud networks. And then we actually do all of the routing of the traffic automatically. We set that up automatically. We can scale out, and we keep track of where the traffic goes so that it always gets sent back to the main firewall. So we do that by doing bidirectional hashing so that we can keep track of which firewall it goes to. And then we can support things like the gateway load balancer from AWS. Same configuration, except for now we're going to route it through the gateway load balancer and use that if you're wanting to use the connectivity to that for the Palo Alto or the Checkpoint firewalls. And then let's see. simplified solution for overlapping IP spaces. A lot of our customers really want this because they're connecting a lot to their customers and they have overlapping IPs. So we're going to handle all the natting and denatting really easily. And so we just need 4 different IP addresses that we put in there: the customer's destination address, the customer's virtual IP, the cloud virtual IP, and the cloud destination IP. So what happens is the cloud virtual IP is the only thing that you have to give to the customer. The customer now has that, and that's how they talk to your network. So we push all the rest of these IP addresses into our gateways from the controller. So now when the customer comes in using their cloud virtual IP, we will NAT that, get it to where it needs to be in the cloud, and then we'll send it back to our gateways, which will DNAT it and send it back to the customer. So it becomes a very clean way that you still get to monitor all of this traffic and have consistent visibility across your network. And then finally, I think this is the last one, to be able to leverage guard duty and the VPC internet ingress gateway. So there's a bunch of pieces here. There's the Amazon guard duty. There's the VPC internet gateway ingress routing, which is going to take traffic coming in and route it through our gateways. There's the Aviatrix controller, which is going to understand all of this and put it together. And then there's our gateways. So basically, we go to Amazon's guard duty, we pull in the findings, and we push those to our gateways. So now our gateways know which IP addresses that it's looking for. So now when traffic comes in through the ingress router, it forwards to our gateways. It looks at it as a stateful firewall and decides, should I block that or allow it? And if I allow it, it passes it to the EC2 that it's supposed to talk to. Now, we also do micro-segmentation. So we have the ability to, say, group segmentation together. So I might have an internal customer that can see everything across different VPCs, even into another cloud. Or I might have the partner that can only have access to this particular VPC. And then I might have customers who have access to my applications in both AWS and Azure. So I can set up all of these different segmentations between different groups. So in the end, if you want a little bit more, come visit us at the booth this afternoon or tomorrow. We can give you details on any of this. We're doing a bunch of look for immersion days where you actually go through and get your hands on a workshop and understand how all of this works. And then we have this flight training where we have a bunch of different things, workshops that you can sign up for, or our Aviatrix ACE, which is a certification program similar to CCIE that we've had about 20,000 people go through and get certified and get a lot of positive feedback on that. So with that, we'll go to Q&A if there's any questions from the audience, or I'll be around afterwards for a little bit and we can chat. I also see a few Aviatrix folks here that can answer your questions.
Yeah, and if anyone does have questions, I can definitely bring you the microphone if anyone wants to raise their hand. If we have anyone, you've answered all questions.
Question? Any comments, cuss words, anything?
Hey, there we go. Thank you so much, Rod. Thanks, everybody.